Okay, I'm going to talk to you about some of the questions that are on your midterm study guide. In this section, we'll be talking about the ones that go along with the composition of functions from section 2.8. So I'm starting on a problem like your number 66, where you have an f of x function as x plus 4, and then a g of x that's x squared minus x, and you're asked to find f plus g at 2. So we can do this a couple of ways. We could add the two functions algebraically, like take this x plus 4 plus the x squared minus x, add that together first, then plug in the 2 for x. Or we could just plug the 2 in for the x's, work them out individually and add them. So you have choices. I'm going to demonstrate both of those. First of all, f plus g means take the function f, the function g, which is x plus 4 plus the x squared minus x. And we could add that algebraically if we wanted to. You'd see the x and the x cancel out, and you have a 4 plus x squared. Okay, and then it says plug in for the x's. So now we just have that one x term, so it's 4 plus 2 squared, or 4 plus 4, for an answer of 8. All right, and that's kind of the basics of how we use the function operations. We can add, subtract, multiply, or divide functions. And then there's one other thing we do in this section. It's called f of g of x, where we put a function in a function. But that's kind of in a nutshell what you're doing on this section, different operations with functions, multiple functions. Okay, so I said I'd show you that other way as well. You might prefer this because there's less algebra involved. We can just plug in the 2. If there's a number here, that means you can plug this in for the x's and work it, and then it'll be arithmetic. You won't have to do as much algebra. So we plug in x in the first function. So x is 2, 2 plus 4 is 6. Then we plug in 2 to the next function. That'll be 2 for that x, so 2 squared minus 2 for that x. That's 4 minus 2, which is 2. And then whatever it says to do, add, subtract, multiply, or divide. In this case, it says to add, so 6 and 2 is 8. And notice exactly the same answer. So your choice, whichever one you think is easier. But that's kind of the, I would say, the sum of what we're doing in this section, different operations on functions. All right, so we'll practice some more. Number 67. Again, new functions. F of x is defined in my example as 4x squared plus 5. And then we have a g of x defined as negative 4x plus 3. It says to do f minus g at negative 3. I'm going to demonstrate it the second way I showed you over here and do the negative 3 individually and then subtract my two answers. So first of all, do f at negative 3, do g at negative 3, and then subtract your answers. All right, so here we go. Here's f, plugging in negative 3 for that x, and it says to square x. All right, so you can use your calculator. You know, of course, here your calculator should know order of operations, so you type this in carefully. But by hand, that'll be positive 9, which makes then 36 plus the 5, so 41. So f of negative 3 is 41. Then we do the function g. G of x is negative 4x. You see that negative? It's negative 4x plus 3. It could be anything. So it'll regenerate when you do your problem, but I do have a negative on this example. So I want to pick that up. That'll be 12 plus 3, which is 15. And then we can add, subtract, multiply, divide. This particular problem says to subtract those two answers, f first. So f, you know, because subtraction, you need to do it in the correct order. It's not the same answer backwards and forwards. So be careful. It does say f in front minus g. So 41 minus 15, subtracting that is 26. Positive 26 is your final answer. Okay, number 68. Let's see. No, 68 is a little different. I'm going to say it keeps being the same theme, but this one has the little open circle, which is the composite function notation. The open circle means g of, we read that like the word of, f at negative 1. So anytime you see this little open circle, that means we're going to plug an entire function into another function. And we plug the second function always into the first function. So function f, which is x plus 3 defined here, we're plugging that into function g for that x. So we could write, instead of x squared, we'd write it as x plus 3 squared. Then we're going to plug in 1 for the x value. Anytime there's a number in this parenthesis, that's normally where the x value would be. That's what we plug in for the x. So we have 1 plus 3 squared, which will be 4 squared for a final answer of 16. There's other ways to get that answer, though. I should note that you could have done f of 1, the innermost part first. Do f of 1. Let's do that. F of 1 would be 1 plus 3, 4, and then plug that answer into function g. So that would have a little less algebra. Again, you could do it with the numbers and more arithmetic. But f of 1, you can see that is 4. Then plug that into function g. So 4 for x, 4 squared. Again, the same answer, 16. So either method, whichever one makes the most sense to you, absolutely fine. All right, number 69 takes us back to this domain and range question. And it asks us if we remember, how do we find the domain of a function? We're using the f of x notation, so that's like y equals x plus 1. You might recall that's a linear equation. Anytime x and y are both to the first power, that means it's a line, a linear function. And all the lines, unless just a line, but that's going to be some sort of linear equation. And we know the domain from left to right, it opens without any restrictions left and right, so it's all infinities. And really, I call these the friendly line. Whenever we're doing a linear equation, they're just friendly, meaning there's no restrictions on the domain or the range. We can kind of count on these negative infinity to positive infinities anytime you recognize it's a linear equation. All right, so back to what we were doing on 70. We've got another operation with functions. So this one is similar to one we've seen before, an addition. So, we talked about how you can do that a couple of ways, but we're going to plug in a -6 for our x's. So function f, when we plug in a -6, will be -6 minus 3, plus function g, plug in -6. And you kind of want to be careful when you plug a negative in to be squared. The negative is part of the base here, and it's all getting squared, that whole number plugged in for x. So -6 squared with a parenthesis around it will make a positive 36. And then subtract the x, again because it's negative, you're going to have subtract from the problem and then a negative on the 6. So a double negative, it's going to make that positive. Of course, your calculator can do that. If you just want to let your calculator do the work, just be careful how you type it in. Watch out for that. Let's see, what is that? I think that is 33, positive 33 for that. Okay, number 71. A problem like your number 71. Okay, this time we're going to add, subtract, multiply, and divide, and we're also asked to give the domain and range. We're going to do a couple of problems like that. Now notice here it says f plus g at x. So there's a specific number plugged in for these. So we're going to keep it algebraic. We won't be able to do that. Like I talked about earlier, we can kind of avoid the algebra. We're left with algebra. There's not a number to plug in on these. So we do have to just do the algebra. All right, so first of all, f plus g means take the function f plus the function g and just combine any like terms. That's really all it's saying. So what terms do we have here? A 3x and a 2x is 5x, and a 2 and minus 3 is -1. That is your first answer. It adds to be 5x minus 1, which is a linear equation. Again, it would be y equals the composite function equals, so that is a line, the friendly line. So the domain of a line is going to be negative infinity to positive infinity. Question 2 or B part, now subtract. So function f is this 3x plus 2. Because it's subtract, I will have to be a little more careful when I subtract g. I need to know that the subtraction will distribute and make that a -2x, which we kind of would expect that, but then makes that a positive 3. So we have 3x plus 2 minus 2x and a plus 3. So 3x and 2x is 1x, and then 2 and 3 is 5. So your answer will be x plus 5. Again, a linear equation. Y equals, or f of x equals x plus 5 is a line. So negative infinity to positive infinity. Okay, then we're going to multiply fg. Notice they don't show a symbol between f and g, but it's understood to be multiplication. So multiplying function f times function g will look like the FOIL method. 3x plus 2, that's function f, times 2x minus 3. So we know that binomial times binomial, we FOIL that. So the first times the first is 6x squared. Outer outer is minus 9x. Inner inner is plus 4x. And last times last is minus 6. Then combine any like terms, 6x squared. And then negative 9 plus 4 is negative 5. And then minus 6. Now what is that? What kind of equation is that? It's actually our parabola. Do you remember y equals x squared? Anytime you have a quadratic, it has the shape of a parabola. So a parabola shape has a domain that opens left and right without bound as well. So all the answers for the domain so far, every time it's been negative infinity to positive infinity for the domain. It might not be on this last one though. Last part, D part. And I'm running kind of out of room there, sorry. We're doing a division, f divided by g. Let me kind of get this out of our way so it doesn't run into this part of it. Okay, so we're going to divide function f and function g. Let me just write it up here. Here's function f, 3x plus 2, divided by function g, 2x minus 3. All right, that one is not a line. It's not a quadratic. It's actually a rational function, a fraction function. We're going to learn more about these actually in the next chapter. But for now, just know the domain is going to be restricted. If we graph this, there's going to be a problem with the denominator. Whatever makes your denominator equal 0, we cannot have in our domain. So we say we can't have x equal to 0. So what would make 2x minus 3 equal 0? And then solve that equation. Maybe you just kind of know it from looking at it, but if x is 3 over 2, we're going to have a problem. If we were making a t-table, and that's what domain means, if you were making a t-table of values and looking for x values to plug into this equation, what could you use? On all the other ones, we could say, well, x can be anything. We can plug in anything we want for a line, or even for that parabola. Anything was okay for x. But not so on this fraction function. And again, this is y or f of x equals all of this, making it an equation. So again, if we try to make a t-table and plug in 3 over 2, which I doubt that's just the number you would probably pick, since it's a fraction, but that would give us a problem. 3 over 2 would cause it to be undefined. Our calculator would give us an error message because you cannot divide by 0. So we say the domain, and again this will be on your D part answer, the domain would be negative infinity to the number 3 over 2, then we would put a parenthesis, meaning we're not actually going to include 3 over 2, but all the numbers really close to that, then union 3 over 2 to infinity. So that's the way we write out the domain when we're just skipping number because of the denominator. And you'll see that happens on all the fraction examples. There's always just one number you cannot use. The other problem that kind of goes along, the other what I call troublemaker with domain is when you have a radical. So if you have a fraction, it's whatever makes the denominator 0. The other issue is when you have a radical involved. So when we do this one, we'll have to say we can't let the radicand, the stuff under the radical, be negative because it makes it imaginary. Over here it made it undefined. Here it makes it imaginary if you have a negative under your square root. So we're only looking for things that are real in our graphing world. So that'll be our domain issue here. And then of course if you have a fraction, it's whatever makes the denominator 0. Alright, so let's tackle this one. For f plus g, first of all let's add them and then we'll talk about their domain. Okay, so f plus g would be square root of 6x minus 1 plus 1 over x. We really can't add those together. That's really kind of just the answer right there. F minus g, we'll write it with a minus. F times g, we'll write it with a times sign. So these don't actually add or multiply or simplify very well. And then divided by will be radical 6x minus 1 divided by 1 over x. when we divide by the fraction, it's the same as multiplying by its reciprocal. So we could clean that up a little bit and call it times x. All right, so there's your 4 answers: add, subtract, multiply, and divide. The hard part on this one is what's the domain of these? They've got 2 problems. For one thing, we can't have anything that's going to make this negative, so the 6x minus 1 needs to be greater than 0. So whatever's under this radical set has to stay greater than 0. So we can solve this and we get x has to be greater than or equal to, actually it can't equal 0. We just can't have a negative. So that part of the problem, we find out that we can have 1/6 or larger. And then down here, we cannot plug in anything that makes the denominator equal 0, so x cannot be 0. So our domain for the fraction part is -infinity to 0, union 0 to infinity. So when we do the compilation of these, add, subtract, multiply, well, the divide, this one flipped out of the denominator, but these first 3, it has to meet these 2 requirements. For one thing, it has to be greater than 1/6, and it can't equal 0. Well, if it has to be greater than 1/6, you're missing 0 anyway. So this kind of encompasses this answer. So this takes care of the whole issue. That is your domain on A, B, and C part, and actually on D part because it only had the issue with the radical. So the domain is just the 1/6 to infinity. All right, we'll come back and talk about that a little bit more in the next video.